In this video I want to show you how I constructed this hood, which is a hood over a mounting base for a electronic device, and it's a closing hood. We can look at it from the bottom. It's got some mounting holes, it's got an inside structure, 2mm walls, and so on. So I want to show you how I constructed this from first having the mounting plate as such. I want to show you how I did it. So before we start, let's delete what we have. In the comments to the video or in the description you can find a download location if you want to do this step by step, where you can find this particular file without the hood. So normally we would say, okay, we create a new body, we create a shape binder, and then we start to construct based on the shape binder. But this time I want to show you a different approach, which in some cases may even be the easier approach, and it also shows you a couple of things around a relatively new function in FreeCAD called a carbon copy. And at the end of the video I want to show you some other things that you can do with this carbon copy function also. So let's start and begin. The construction of the base is fairly straight ahead, and let us switch everything off first, and also let us switch off the sketches as they have evolved during the construction of this simple piece. So first there was a block, and in that block I created some insets, another set of insets, holes to hold some metal sheet in the insets, holes for the hex nuts that are at the lower side, and a couple of pads to keep the whole structure a little bit above ground, and so on. But we don't need everything. What we need is the things which are visible on the upper side, and that's the main sketch, and that's the insets and probably these things. And we need the mounting holes, because these are meant to be screwed through the body. Let us see the stuff as it is in this particular step of construction. We have these holes and we have the insets. So we start by switching to part design. I've done this with a relatively new version at the time of doing the video, 5998. That's one of the last versions that came out before we soon can expect the release version. Okay, so create a new body. For those who are still unclear, a body in FreeCAD part design should always be a piece that is one piece in itself. So this body has got its own origin. We start by creating a new sketch in the second body. We put it on the XY plane. In the model tree we switch off pocket 006, and what we actually want is we need a reference for the holes, and we need a reference for the outline, as well as a reference for this edge here. So when we start the carbon copy function, we see this box symbol, and in the moment we move over one of the elements from the other body, it turns into a no way sign. So how can we solve this problem? There is a modifier key that's called the strg, or the control key, or the command key, depending on your keyboard. And if you press this one and move the mouse to one of the elements, you can see the element gets yellow and the box symbol appears. So you can click it, and some of the elements unfortunately can't be clicked. If we try these circles, for instance, or if we try the outer structure of this circle here, no way. The reason is, we can read this at the lower left. It would create some cross-reference which is not allowed at this present time. But fortunately, the elements that we need, like these circles and these edges, they are all possible to be transferred. So we can stop this now, and to make it a little bit clearer, we switch off the display of the whole body, so we see what's in our sketch and what is not from the sketch, from the other body. We select all these constraints which have been transferred with the carbon copy. Carbon copy transfers constraints when it transfers the elements. And as you saw, I only clicked one element and that copied a whole sketch. Elements that you don't need, you may delete in the new sketch, but be carefully, sometimes this kills your constraining in the new sketch. It doesn't influence the old sketch, but it influences the new sketch. If you delete one element, you may delete the constraints of the element that you still want to have. So if you don't need an element, better is to switch this element to construction mode. What we do now with our constraints after I selected them is I put them into the so-called virtual space. The virtual space is sort of a layer or something where we can hide constraints that would just clutter things. Okay, I gotta select them once again. Move the mouse too much while talking. So out from here. Now we see we've got some elements which are construction geometry and some elements which are real geometry, as we transfer them from the other sketch. Now we could do this several times depending on which stage we have in our new sketch. What I do is I leave them all in here, and I leave them in here as they are. Not just that, I convert some of them that we later on will need to real geometry. So as you may already know, if you try to create a feature or a pad or something like that from this sketch, you will fail because it's got self-intersections and all the stuff that's not possible. But we leave it as it is. We have some degrees of freedom that we can solve. So these two need to be over each other. We still got one more degree of freedom to make it complete. So this gotta be on that line, and now the sketch is fully constrained. And what we do is we name this sketch, and we name it transfer. So that makes it obvious that we are not going to create anything from that sketch. We just use that sketch for external references in the actual working sketches. And now let's start with them. So the first is, what I create is a block from these 4 lines. We create a new sketch, XY plane, and now we select with external geometry. We need this, oh, no more. We create a rectangle from here to here. We can switch the transfer off. We've got 4 degrees of freedom. Okay, they have not synced yet. Where else? Here and here. Good. We can close it. So from our sketch we can create a pad now, and I make this 30 millimeters high. We switch on the original body. We can see it's not exactly there where it ought to be. We can later on transfer, or we can, right where we are, we transform this upwards so it's there where it ought to be. Good, so switch the first body off again and continue in the second body. We switch on the transfer sketch, switch off the pad. Next is we want to have the inner cutouts for the hood. So new sketch, XY plane, OK, and I will create 2 rectangles first, and then I use the trim function to trim away the inner pieces of these rectangles. So there we got it. Then I decide to have these 2 same length. I want to have these also same length. I want to have it symmetrical to the center point. So next is I want to have a distinct distance from here to there, and for this I need external geometry, which I can now easily get. So I want to have this with a distance of 10 millimeters for the time being. We may later on change this. So this one won't move because it's symmetrically. We still have these moving in size. So we give it a size, and I start by giving it 6 millimeters. So what else is to be done? So we still have some movements in this length. Gotta make them equal to So now we can move it this way, no more this way, and we have to define how far this is away. And as I want to have a 2 millimeters wall, I create this distance with 2 millimeters. In this distance the wall is thicker, so that's not good. We need it thinner, and we can do this by changing this measurement and create a 2 millimeters measurement here. So now we have the 2 millimeters wall, and that one can be taken away. By principle it looks well, everything is good. We can close it, and now we can create a pocket. So how far do we pocket in? First we have to pocket in reverse direction, as you can see, so that it moves inward. And the dimension, that's something we can derive. We have the pad 002, and we can just say, we can key in the equal sign, and we type in pad 002 and then LE for length. And as we know, we would like 2 millimeters of thickness. We can key in a 2, and it tells us in compatible units, because there it wants millimeters. So this brings us to 28 millimeters. That's better than taking a real value, because now if we change from 30 to, let's say, 35 millimeters, it will grow to 33 millimeters. And it's always a good choice to work with these calculations here. Good. So next thing, switch that one off again. We need a couple of holes. Create a new sketch, XY plane, OK. We need holes. So there's several possibilities. Let's just take the reference hole, create one hole, make this hole a distinct diameter, and I'm taking 1 millimeter, so it gives me a diameter of 2 millimeters from 1 millimeter of radius, and that gets a little bit smaller after the print, and it's good for putting in a self-cutting small screw. We close this, we make this pocket 15 millimeters, that's far enough. What's still missing is the pocket doesn't protrude inside, we need to reverse it, and now it's going inside. And the next thing is we want to copy this over to the other 3 locations, and this time we have to do a multi-transform feature, because you can't mirror a mirrored feature in 2 steps. You need to do this in the multi-transform feature. So that's what we find here, the multi-transform feature. We already selected pocket 008, and in this window we click with the right mouse, we add a mirrored transformation, and we want to have the horizontal sketch axis. Brings us this hole. We click again, right mouse, mirror transformation, and this time it pre-selected the vertical axis again, and this time it mirrored over both holes. So we could have done it vice versa, that's no problem. At least we've got the holes as we wanted them. So finally, a little bit of touch up. because it's going to be a 3D print, and 3D prints have some things that are making it easier for the printer. For instance, if you don't apply too hard corners, it's a little bit easier for the printer. And to achieve this, what I'm going to do is I switch to wireframe. I will select 1, 2, 3, 4 lines, make a chamfer, 3 millimeters, that's fine. And for the outside, where it's even more important, because steep corners, rectangular corners, sharp corners, so to speak, they are easy to create some ripple when your printer stops fully and changes direction. If the printer can move around, then it's easier. It's similar with CNC machines. There are some structures which are better and some are worse. And here I found out if I do a little bit of chamfer around it, it will make it easier for my printer to create a nice surface. So switch back to the normal view as it is, and voila, we are ready. Our hood is complete. We switch on our main body again, and that's what it is. Okay, so that was for constructing this little piece using the carbon copy technique. And while we have the carbon copy, I would like to show you a couple of other tricky things you can do with the carbon copy. We go into our main body. We activate this body, and let's assume we want to create something here and use the same holes as we have at this place, or these holes. So what can we do? Let's first create a simple block. I put this block here. Get me some external geometry. A point-on-point coincidence. Come on, get it. Good. Why not? Oh, we have something too much. Now it works. Fine. We close this one. We pad it 30 millimeters. And now I want to have a sketch on this plane, and we all know it should not be done, but I'm doing it here. I create a sketch directly on the face because it's for demonstration only, and it won't break. There's nothing gonna break. So if I want the same structure as I have here projected to this face, how can I achieve this? Well, we can again use the carbon copy function. We start a carbon copy. Obviously it's not going to work, but if we click the Control key and the alternate key, we are able to select it, and as you can see, it jumps over and projects it in a rectangular manner, so it lays flat on our new sketch. obviously not exactly at the position of the block, but at least it's now on the same plane. And we could move this around and so on. So to transfer something across two planes which are not parallel, you need the Control Alt function. So that was how to copy something over across rectangular planes with the carbon copy function. Thanks for watching. I hope you've learned something. I hope you enjoyed it. And if you like to buy me a beer, you can find my PayPal address in the description, and look forward to more videos from me. Bye.